Okay, everybody, welcome to your next lesson. This is going to cover exponents. And let's go ahead and read our learning target. Today, your learning target is that you, the student, will basically solve exponent problems. That's what it's all going to be about. Okay, so let's just kind of talk about the ins and the outs of what an exponent really is. Okay, an exponent is a small and raised number high and to the right of a base number. Okay, so that's basically what it is. I bet if I were to ask you guys all to show me what an exponent is, you guys could all do it. But right here, what we have is a very basic exponent. This big number, that's your base, and 4 is your exponent. That's your power. An exponent tells you, if we look at the definition of an exponent tells you how many times a number is multiplied by itself. So we have the base 3 and it's being multiplied by itself 4 times. An exponent is read 3 to the 4th power. So we say the base and then we say to the whatever power it's written as. Okay, so 3 to the 4th power. But back to what an exponent is. This is probably the most important thing, is that you all understand what an exponent is, and it's also important to know what it is not. An exponent tells how many times a number is multiplied by itself, which I covered just a minute ago. So this does not mean 3 times 4. Do not do that. That is definitely not what you do. 3 to the 4th power is actually 3 times 3 times 3 times 3, which is not the same as 3 times 4. 3 times 4 is 12. 3 times 3 times 3 times 3 is not 12. You're thinking maybe 3 plus 3 plus 3. That would work out. Exponents don't do that. Exponents show you that a number is being multiplied by itself repeatedly that number of times. So it's going to be much bigger than 12. Okay, some alternative ways for writing. Okay, again, let's go back to how to read an exponent and just kind of talk about some common exponents that you might encounter. You know, that could be said as 3 to the 2nd power, but most commonly it's going to be referred to as squared. So 3 squared. So if you have a 4, that's going to be 4 squared. You know, 5 to the 2nd power is also 5 squared. 5 times 5. 13 to the 2nd power is also 13 squared. 13 times 13. Do not confuse that with times 2, because it does not mean the same thing at all. Another common exponent that you're going to encounter is the power of 3. And that is commonly referred to as cubed. You can say it as power of 3 as well, but it's also cubed. You can say it as cubed. And that kind of comes from literally a cube. You know, let's say I asked you to find the volume of a cube. Well, cube has all equal sides. So this side equals this side, which also equals this side. So all the sides are the same. You know, you were taught probably in 5th grade that you find the volume of a rectangular prism, which is also a cube, as doing length times width times height. So the same thing would apply to this, and that's kind of where it gets its name, cubed. Okay, so here's some where I want you guys to read them, and in your notes just write them. So 3, how would you say this one? 3, it's got a little 2 up there. How would you say that? How would you say this? Hit pause and write them down. Just see how you do. Really not that difficult. Okay, now here's some examples where I have the multiplication all written out. 2 times 2 times 2, what would that be as an exponent? So 2 times 2 times 2 is the power of 3, because we're multiplying the base 1, 2, and 3 times. How would you write this? Well, how many 3's are there? There's 2. So our base is 3, because that's what's being multiplied. And how many times is that being multiplied by itself? Twice. You also might notice that I haven't really done any multiplication yet. We're going to get to that in just a little bit. I just want you guys to get comfortable right now with reading and writing them, and then we'll get into what they actually multiply out to at the end. Okay, here's another one. 5 is our base number. Count how many 5's there are. How many times is 5 being multiplied by itself? And that would be 4. 5 to the 4th power. Here's another one. We have 8 being multiplied by itself, seems like 4 times. So 8 is our base. I left both things blank here. And how many times is it being multiplied by itself? 4 times. That does not equal 32, by the way. Remember, get that out of your head, that equals 32. Actually, forget I even said that. It does not equal 32 at all. It's much bigger than 32. In this example right here, we have a number of 7s. So 7 is our base. That's the number that's being multiplied by itself. And then just count how many times it's being multiplied by itself. 1, 2, 3, 4, 5. So this is going to be 7 to the 5th power. Next, look at 9, and 9 is being multiplied 2 times. So 9 is our base, and 2 is our exponent, so 9 squared. Now, last thing I want to do here is just kind of talk about how to multiply these out. Like I was saying earlier, 3 to the 4th power does not mean 3 times 4. It means 3 times 3 times 3 times 3. So if you want to multiply this out, just go left to right. Never going to be a shortcut to do 3 times 4, ever. Never, ever, ever will it be a shortcut. So just go one by one. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So there you go. 3 to the 4th power does not equal 12. It equals 81. Get it into your head that a power means you're multiplying it that number of times by itself. Okay, so let's practice here putting it in expanded form and standard form. Standard form is when you take something like this, 4 squared, you write it out as what it would look like as a multiplication problem. So 4 squared means 4 times 4. So that's the expanded form. Standard form of 4 squared is going to be what that equals. So 4 times 4 is 16. That's like your product, basically. What did that all multiply out to? And we get 16. 4 times 4 is 16. Here's another one. 2 to the 3rd power in expanded form would be 2 times 2 times 2. What does that equal in standard form? It does not equal 6. It equals 8. 2 times 2 is 4. 4 times 2 is 8. 3 squared in expanded form is 3 times 3. 3 times 3 equals 9. That's a very simple one to do. 5 to the 3rd power means 5 times 5 times 5. 5 times 5 is 25. And 25 times 5 is 125. So there you go. This is much bigger than 15. As you can see, hopefully you're listening and paying attention here. But you can see that 5 to the 3rd power and thinking that as 15 was not even close as a shortcut to figuring out 125. Not even the same ballpark. So 5 to the 3rd power means 5 times 5 times 5. Here's some other ones here. Just as an extra bonus feature here, just want to talk about this. What if the exponent is 1? And if the exponent is ever 1, don't think of it as multiplying by 1. Whenever an exponent is 1, it is equal to its base. So 8 to the power of 1 is 8. 4 to the power of 1 is 4. 35 to the 1st power is 35, etc., etc. Likewise is true with numbers that don't have an exponent. If they don't have an exponent, you can automatically assume that its power is 1. Lastly, if the exponent is ever 0, product will always be 1. No matter what kind of number it is, it will always be 1. Even if it's 1,000 to the power of 0, the answer is 1. 476 to the power of 0 is 1. Understand that.